Hello everyone, it's Powell, and in this video I'm going to show you how to graph a circle from a circle equation that's in standard form. And there's two different forms the equation of a circle can be in. There's standard form and general form. General form you usually see in trigonometry and pre-calculus. Sometimes you see it in Algebra 2, but it's when you talk about conic sections. The standard form equation you see in geometry, Algebra 2, and trigonometry, so we're going to start with this one. Now the standard form of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. And this equation tells us some very important information, and one of them is the center, which is at h comma k. This is also sometimes called hk form because there's h's and k's. Now, the center is at h comma k, but notice that h is being subtracted from x, so there's going to be a little bit of a sign switch there that we'll see when we get into our examples. And our radius of the circle is the square root of r squared, or r. So you'll always have r squared on the other side of the equal sign, so you have to take the square root of that to get the radius of the circle. So our first example is x plus y squared equals 49. Now you'll notice if we compare this with the standard form equation, there's no h or k being subtracted from x or y, so our center is at 0, 0. Because it's technically x minus 0 squared and y minus 0 squared. And our radius is the square root of 49, or 7. So to graph this, we're going to put our center at 0, 0, and we're going to go out in every direction 7 spaces. I've already done this ahead of time. And what you do is you draw your best circle around each point. Now, it doesn't have to be perfect, but just don't do this. That's not a circle. Your teacher won't like that. So just do your best circle. It's close enough. Not close enough for perfectionist. That's better. Now, that's centered at the origin. This next example is not centered at the origin, and it's x plus 2 squared plus y minus 3 squared equals 5. Now, remember, as I said before, the x and y coordinates are the numbers subtracted from x and y inside the parentheses. So if we have x plus 2, it's x minus negative 2. Because negative 2 is being subtracted from x. And with the y, it's a little bit more plainer to see that it's y minus 3, so your y coordinate is 3. And the shorthand is it's the opposite of the number inside the parentheses with x and y that will give you your x and y coordinates, respectively. Or it's the x and y value that will make the inside of the parentheses 0. There's a lot of ways to describe it, but the shorthand is it's the opposite of the number with x and y. And our radius is square root of 5, which is about 2-ish, a little bit more than 2. So we go with our center is negative 2, positive 1, 2, 3. And we're going to go square root of 5, which is about 2.2, 1, 2.2, 1, 2.2. Again, it doesn't have to be perfect. We're just sketching a graph. And 2.2. You get your circle there. And that's a circle at the center and a circle not at the center. Now, if you look at the standard form equation, you have x minus h squared plus y minus k squared equals r squared. So you might be thinking to yourself, or you might have noticed, that the equation of a circle in standard form looks very similar to the Pythagorean theorem, because it's something squared plus something squared equals something squared. And you would be right. The circle equation is related to the Pythagorean theorem, but it's more closely related to the distance formula. And the reason that is the definition of a circle is the set of all points equidistant from a specific point, which is the center. And since it's distance, since it's the set of all points that's the same distance from a center, obviously it has to be related a little bit to the distance formula. And a lot of times it's not, when you first learn about circles, you get a circle that's filled in all the way and you say this is a circle. But the algebraic definition of a circle is the set of all points that's around the center. So the center is actually not part of the circle, and neither are any of the space inside the circle. It's only the outside. And there's your circle, or both of our circles. If you like this video, please subscribe below, and we will definitely be continuing our discussion on the graphs of conic sections like circles, ellipses, parabolas, and hyperbolas. And please comment below on any topics you'd like me to see in the future. And it is May 4th, so happy Star Wars Day, and may the 4th be with you.